Hello, my name is Mahesh Fund and I am third year ENTC BTech student at the GHRCM Pune. My project name is Smart Home Automation System using the Arduino and sensor integration. Before heading towards the main objective of my project, I have one question. That is there any person in the world who don't want comfort? No, we all want comfort. And the my project brings a comfort and convenience. It also has the safety and security. And it is the energy efficient as well as cost efficient project, because when no one is in the room, the appliances reduces the consumption of electricity. My project objective is what we aim to achieve is the automated climate control. We implemented the automatic fan and light control driven by the real-time environment data, like LDR sensor. We use the LDR sensor. If there is the darken in the room, the lights will glow. The more darken, the lights will glow more brightly. We also use the multi-sensor and data monitoring. We monitor the temperature of the room, humidity, light intensity, and the occupancy means the distance, if anyone is present in the room or not. And according to this, the lights are turned on or off, as well as the fan using the temperature. Okay, the main part is here. The core components of our system, we use the Arduino Uno. Arduino Uno is the brain of the system. It handles all the sensors, sensor inputs, and controlling the actuators. It gives the command to all the sensors actuators. DHT11 measures the ambient temperature and the relative humidity. It with the moderate accuracy. It has the accuracy for the humidity is plus minus 2% RH, and for temperature it has plus minus 5% accuracy. We also use the ultrasonic sensor. Ultrasonic sensor detects the presence of the person in the room. LDR sensor, as previously said, the LDR sensor is used to sense the intensity of the light, and according to the it brightens the light in the room. Actuators, we use in this project, we use the servo motor, because we are stimulating project in the PICSimLab. Okay, and the software PICSimLab is used to simulate and debug the project. Now our system architecture is, our Arduino Uno is the brain of the projects. It handles all the sensors actuators. Okay, it handles the lights. It senses the temperature and humidity and tells us via the LCD display we use. Ultrasonic sensors is measures the distance. LDR, LDR is used for the ambient light detection, and the servo motor is used as the fan to turn on or off by detecting the person. Working principle, as climate control. As soon as the temperature of the room exceeds the 30 degree Celsius is our threshold temperature. We can change this. The servo motor starts to rotate, means our fan will start when the temperature exceeds the 30 degree Celsius. Also, the smart lighting system, the LED lights will turn on only if the darken is in the room. It means during the night. and also the ultrasonic sensor detects the presence nearby. We use the 16 by 4 inch LCD display to continuously get the updates on that display. We displayed the live readings of the temperature, humidity, distance, and the light intensity values. This is the we implemented the project in the Arduino Uno. Arduino Uno is the IDE we use to write the code and compile code, and we simulated in the PICSimLab. Okay, our key pin assignments are these are the pin assignments that we use for the sensors to the Arduino Uno as input output. This DHT11 is connected to the digital pin 2 of the Arduino, and the function is data input, as well as the ultrasonics sensor pin are attached to the digital pin of Arduino 9 and 10, trigger and echo respectively, to detect the distance or presence. Similarly, we done for the servo motor and the LDR sensor. These are the Here is the brief overview of the libraries that we use in the project. The essential libraries are the DHT.h. This is used for the DHT11 sensor to read the temperature and humidity. Servo.h. This library is used for the servo motor, and liquid crystal.h is used for the LCD display. These are my results and the observations from the project simulated on the PICSimLab. Later on, I will give you the demo of the project, that how project will work. This is the picture of how is it works. It shows the temperature. We can say the temperature is 39.2 degrees Celsius. Humidity is 33 degree, and the distance means no one is in the room. That this is 107 centimeter, and L is known as the light. We use the L. This shows us the intensity of the light. The status of fan and light we can clearly see here. Here is the results. We get the 100% automation accuracy. We use the 4 real-time parameters, that is the temperature, humidity, distance, the light. Next, future enhancements. We can connect this system to the cloud platform like ThinkSpeak for the remote data logging and historical analysis, as well as there is the Blink IoT app. From there we can control all the connected sensors in the appliances, but for that we need the Wi-Fi modem. We can also use the mobile control to develop a mobile application for manual override and remote monitoring for the appliances. We can also do the advanced interface, we can also integrate the voice command functionality, just like the Amazon Alexa or Google Assistant. We can also use the enhanced safety. We can add more crucial sensors such as gas and fire detection to improve the overall home safety. Thank you. Now we will move towards the demonstration of the project. This is my project code. This is our main smart home system IONO file, where we declared all the libraries, and the definitions of the libraries is here. Here we define the libraries. Then we begin the LCD display DHT sensor, ultrasonic sensor, LDR sensor, and fan. In the loop, we continuously use to measure the values of the temperature, humidity, and ultrasonic sensor. Here we use the loop. Here we use the decision statements if else. If temperature is above 30 degrees Celsius, then the our fan will automatically turn on. And also for light control, we use these levels. LDR sensor has the levels from 0 to 1022. Means when its value is less than 400, means there is the darken in the room, and when the distance is less than 20, the lights will automatically get turned on. In this header file, we define the input output pins of all all sensors and LCDs. This is the definition for the DHT sensor. This is the header file used for the DHT sensor, and constant H is the definition of the pins. This reads the temperature values and the humidity values. Here we use the liquid crystal.txt library to write the data on the LCD display. At start, we will get the welcome to the smart home like passage on the LCD display, and then we will see all the temperature readings and values. This is the definition for the LDR pin. This is the beginning of the LDR pin. That means our LDR sensor will be ready to receive the values and send to the Arduino. This is the definition for the servo motor, means our fan. And this is for the ultrasonic sensor to measure the distance or the presence of the person in the room. Now we will go to the PIC first. We will compile this. Compilation is the successful. Now we will create the hex file, that is export compiled binary. Yes, we got the hex file. Now we will open the PICSimLab. We will load the hex file. This is the hex file. Now we will debug spare parts. Modules, spare parts. We can see the welcome to the smart home system. Now this T shows the temperature, our temperature. We can change the temperature from here. Now let's see. When our temperature is the less than 30, then our fan is off. You can see here in the LED. And when our temperature goes beyond the 30 degrees Celsius, our fan turns on. Similarly, when we keep the distance below 12 and the value of the resistor, we put below 400 degrees Celsius, our light will be 400 degree luminous, or light will be on in the room. This means our room is darkened and now we need to turn on the light. This is the demonstration of the projects. Thank you.